So in the last video, we talked about abstract classes. Now we're going to talk about abstract methods. So referring back to my previous example, I have this shape class right here that has this single attribute color. It's got a getter, a constructor, a setter, and a toString. Okay, and then I have this circle class that extends shape, and it adds this attribute radius, and then it has a getter and a setter. Okay, so again, if I go back to my examples of shapes, perhaps that I want to be able to compute the area of all of the different shapes. So maybe I'm writing a program that will compute the areas of triangles and rectangles and hexagons and circles and whatever else. Okay, but I have this generic shape, okay, and so we talked about last time we could make this shape abstract, which would mean that you cannot instantiate shape. You would have to create a subclass like circle in order to be able to use it. So in this case, what I'm going to do is I'm going to actually create an abstract method. Okay, so I'm going to make a method called compute area. So we'll do public double compute area. Okay, and it won't accept any arguments, but what I'm going to do is I'm going to make this abstract. Okay, and so basically what that means is since I'm dealing with this generic shape, I have no way of computing the area of a generic shape because I don't know what shape it is. Okay, but what declaring this method compute area, declaring the method as abstract, what that does is that forces me to actually override this method. Okay, so if I compile this as is right now, I want you to notice a couple of things. Okay, number one, I get this error that says shape is not abstract and does not override abstract method compute area. Okay, and it says abstract methods cannot have a body. Okay, so the first thing, let's deal with this abstract methods cannot have a body. When you declare a method to be abstract, you cannot put in these curly braces or do anything. You just declare it like this. Okay, so it's just public abstract double, the name of the method, and then a semicolon. All right, so you're not going to put in any kind of implementation as to actually computing any sort of area. All you're doing is you're stating, hey, there is a method called compute area that whoever extends me needs to implement. Okay, so if I compile this, now I still have this error saying shape is not abstract, okay? So that leads to the second point. If you create even one abstract method in your class, then the class itself must also be abstract, okay? So I have to actually make this class abstract now, all right? So you can have an abstract class on its own without any abstract methods, which we saw in the last video, but if you want to have even one abstract method anywhere in your class, then the entire class has to be abstract. Okay, so now if I compile this, I get no problems. Okay, well, so now I have this abstract class shape, and it's got this abstract method compute area. So if I go over to my circle class, which extends shape, if I try and compile this class now, you'll see, oh, circle is not abstract and does not override abstract method compute area. Okay, so again, because I declared this method compute area abstract, that means that over here in circle, I need to provide an implementation for that. So in other words, I need to override compute area. Okay, so I could public void, or I guess it's public double compute area. Okay, and then in here I could do my, return math.py times radius, right? So I actually provided a implementation here of compute area. And so if I compile that, okay, now this compiles just fine. Okay, it's not complaining anymore. So because I extended shape, and shape was this abstract class with this abstract method compute area, it is now saying you must override that compute area that was declared abstract. Now, another thing that I could have done, okay, is if I comment this out, I could have also made circle abstract. Okay, so I could have done this. All right. And then if I compiled it, it would compile just fine. And it's basically saying, all right, because you're also abstract, I'm not going to make you override compute area. But now, because circle is abstract, that means I can't actually, if I was to try and do this right here, circle C1 equals new circle, I would not be able to do this because circle is now abstract, so I can't instantiate this. So I would have to create a subclass of circle, call it semicircle or oval or something like that, and then I'd be able to instantiate that. So in this case, what I'm going to do is instead of making this abstract, I'm going to provide this implementation like that. So when I define shape in this way, where I make it abstract, and I have this abstract method, basically what I'm saying is there are these properties of shape, like color, maybe text, maybe whatever other properties of shape you would have, outline, border, color, border thickness, things like that. But they're generic enough that I don't want you to actually be able to create a shape object by itself. I'm going to force you to create a subclass. So like in this case, it would be circle. Okay, you could do rectangle or triangle or anything else. And I'm going to force you to provide an implementation for this abstract method. So for this compute area, I am now forcing you to put this in there. Your program won't even compile if you don't have that in there. Okay, so that's basically what you would use abstract methods for.